Let's solve problem 5.39 for Microelectronic Circuits 8th edition by Sedra and Smith. So we have a table which lists terminal voltages of a PMOS transistor in 6 cases, given that the threshold voltage, V sub t, is equal to -1 volt. We want to complete the table. So let's get some preliminary equations. So voltage from source to gate is simply just voltage from source minus voltage from gate. Voltage from source to drain is equal to voltage from source minus voltage from drain. And the voltage V overdrive is equal to voltage from source to gate minus the absolute value of threshold voltage. As far as regions of operation, if the voltage from source to drain is greater than or equal to V overdrive, that would be saturation. If voltage from source to drain is less than V overdrive, then we would be in triode region. And regardless of what the voltage from source to drain is, if V overdrive, so not the absolute value, but just the value of V overdrive, if it is less than 0 or even equal to 0, we would call this the cutoff region. Okay, this is all the preliminary information. This is really all we need to start solving for the table. So let's solve for case A. Voltage from source to gate is equal to 2 volts minus 2 volts. So that is equal to 0. V overdrive is equal to voltage from source to gate, which is 0, minus the absolute value of the threshold voltage, which is 1, so we get -1. So we could write -1 here. I'm going to write 0, because a negative overdrive voltage doesn't make any sense, basically, physically for the semiconductor device. So I'm just going to write 0. So then voltage from source to drain is equal to, the source is 2, drain is 0, so we get 2. And because the overdrive is less than 0, it's -1, this would be cut off. Okay, let's solve for case B. So voltage from source to gate is equal to 2 minus 1, so that's 1. Overdrive voltage is 1 minus 1, so we get 0 again. And the voltage from source to drain is equal to, voltage from source is 2, drain is 0, so we get 2. For region of operation, I'm going to say cutoff, but also we'll just say cutoff because it's V overdrive is right at 2, so I'm going to just say cutoff. It's very close to triode region, but we're just going to say cutoff. It's really if it's less than or equal to 0. Okay, so for case C, we have voltage from source to gate is equal to 2 minus 0, get 2. V overdrive is equal to 2 minus 1, which is 1. And source to drain is, we got 2 minus 0. So here we have voltage from source to drain is 2, and that is greater than the absolute value of V overdrive, which is 1. So we are in the saturation region. Okay, I'm just going to start verbally calculating these. So for case D, voltage from source to gate is 2 minus 0, 2. V overdrive is source to gate minus 1, so 1. And then source to drain is 2 minus 1, so that's 1. So here we're like right between saturation and cutoff, because here we have V source drive, source to drain is equal to V over drive. So I'm going to put saturation triode, just so like understand that we're right there in that border. Okay, case E, voltage from source to gate, 2 minus 0, 2. V over drive, 2 minus 1. And then source to drain, 2 minus 1.5 is 0.5. And source to drain is less than V over drive, so this should be in triode. Case F, source to gate, 2 minus 0, 2. V over drive is 2 minus 1, so that is 1. Source to drain is 2 minus 2, which is 0. This is less than V over drive, so once again we are in the triode region. So that completes this table. Thank you for watching this video. I hope you enjoyed it. For any questions or video suggestions, feel free to contact me in the comments or by my email, and I hope you have a great day.